One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. Today I'm going to be looking at the complexity of the in-order transversal and how we came about it. Now the time complexity remains the same with stack and recursion. Why? Because we iterate through the entire node in the list to get our solution. And so I'm basically that maps to the recursion and also maps to the stack because there's an iteration to every list because we are taking n to be the number of nodes. So if we get to visit every n on the node, then immediately it means that we have the same time complexity as those other guys, because every iteration we do here, every of the while loop we go through ends up getting us through the entire complexity. So yeah, there is that. So moving past that, we now talk about the space complexity where we see the improvement. So why is there an improvement? There is an improvement for the very reason that there is no recursion stack, right? Because that creates a space on its own. For every stack you visit, there must be a space created for all the variables within that space. And then the second bit is because of the time, is because of the we are not also using any stack, like a real stack where we have first in, first out and stuff like that. So there's no space held in memory. So the memory um is free of any, is devoid of any space usage in the sense of the RAM, right? Now we now look at this guy that uses it itself, that the whole process of pointing back to a current and getting and pointing it back to the none, as a whole process where we now see that the space, we use no space. Basically it's just basically movements, functional movements between the tree that now helps us return this value. So there's no space usage, and that's the beauty of Morris transverter. It just is a space limiting, or a space um what's the word, it's space ideal in a sense, because it doesn't use any space. But one thing the question also spoke about, which is the caveat I was talking about, is that he said the tree shouldn't be modified, right? He says the tree shouldn't be modified. And for that very reason, the very reason that the tree shouldn't be modified tells us that there is another up, right, to the question. Now, this might have the same solution or the same complexity as Morris, but it doesn't modify the tree, because it was Morris actually modifies the tree by pointing the right tree up to the current and then pointing it back to the none. So basically that's a modification in a sense, right? So that's what we are trying to now see how we also mitigate that. And that's the last bit of this problem, where we would have an O of 1 space complexity, a time complexity we are not going to use recursion, we are not going to use stack, we are going to have an O of 1 space complexity, and we're not going to modify the tree. So where the question is fully answered, and every bit of it, every characteristic of the question is truly attended to. So that's what we are going to be moving into next, and that's going to be the last bit. So see you on that one. Muchas gracias. Bye.